Thank you, Mr. Chair. Very good afternoon. Topic of my presentation today is a study where we have attempted to understand the high sulfate concentration in the groundwater of Kuwait using geochemical modeling. So before jumping into the subject, I would like to give an overview on the water resources in Kuwait and the hydrogeology. So Kuwait, country in the Middle East, we share border with Iraq in the north, and in the west and in the south we share border with Saudi Arabia, and we have very long coastal line with the Arabian Gulf. Kuwait is a hyper-arid country. Rainfall is very limited. It's around 110 millimeter per year, and there is no surface water resources. And groundwater resources are limited. So we are water-deprived country with respect to natural water resources. So most of the water comes from the desalination plants, produce fresh waters, desalinated seawater. And we have, these are the main three resources: produce fresh water from desalination plants, and groundwater and wastewater, treated wastewater. And we have lateral recharge of the aquifers from the neighboring countries. The sources of water, desalination plants, the consumption, yearly consumption is 660 million cubic meter per year, which is mainly used for domestic purposes. Fresh groundwater is only 3 million cubic meter per year consumption, and it's again for the domestic purposes, whereas brackish groundwater is 250 million cubic meter. It's used for agriculture and industry purposes. And we have conventionally treated wastewater, both by conventional method and reverse osmosis method, and it's used for greenery purposes and agricultural purposes. So the total consumption per year is 1,074 million cubic meter. We have two main aquifers in Kuwait, which we extract, from which we extract the groundwater. It is Kuwait Group, and below we have Dammam Formation. This is the tertiary stratigraphy of Kuwait. We have the main two aquifers. You can see Kuwait Group and Dammam Hassa Group, where the Dammam Formation comes. And under Kuwait Group, we have three sub-aquifers, Dibdiba, Fars, and Gar. Due to the unique lithology and topography in this area, we have a fresh water in northern Kuwait, but it has been kept as a reserve for emergencies. It's not been extracted except for bottling purposes. This is a land use map of Kuwait. We have two agriculture areas, one in the north and one in the south, and oil fields, and in the central part of the country we have brackish water fields, which we use for industrial purposes and mixing with desalinated water to make it suitable for potable purposes. So now coming to the subject, the natural water resources of Kuwait are practically limited to groundwater resources. So these resources are brackish in nature in the central and southwestern part of the country, and more saline towards the northeastern part. So in general, the groundwater flow direction is towards Arabian Gulf. So apart from salinity, higher sulfate and nitrate concentrations in groundwater is also reported in this region. So this is our main concern now, the higher concentration of sulfate and nitrate in the groundwater, where we have very limited resources of groundwater. So understanding the process behind the high nitrate and sulfate concentration in Kuwait Group aquifer is more important in such water scarcity country. The sources of sulfate, usually the sulfate can be found in air, soil, and water. It's easily soluble in water, and there are many potential sources of sulfate, like gypsum is one of the sources for sulfate, reduced form of sulfur, which are oxidized to sulfate in presence of oxygen, atmospheric fallouts, sulfate in mobile soil, So aquifers like Kuwait Group and Dammam Formation can be sensitive to this contamination of sulfate. So high concentration occurs in shallow and unconfined aquifers that receive large inputs of sulfates from its natural sources. So objective of this study was to attempt to understand the process that causes high nitrate and sulfate concentration in groundwater of Kuwait Group and Dammam Formation aquifers, and also to determine their spatial variations of sulfate and nitrate using geochemical modeling, which include saturation index, log of partial pressure of oxygen and carbon dioxide, statistical techniques such as correlation matrix and factor analysis. So the methodology, we have started with collection of available data, and we have collected groundwater samples from both the aquifers, Kuwait Group and the Dammam Formation. Then we have analyzed some of the isotopic analysis for oxygen 18 and deuterium has been carried out, and analysis for physicochemical parameters like anions, cations. And we have started with geochemical modeling for saturation index and log of partial pressure of oxygen and carbon dioxide versus sulfate concentration, then correlation matrix and factor analysis, then integration of interpretation of result with the GIS, and finally understanding the source of high sulfate and nitrate. So these are the groundwater sampling locations, the Kuwait Group aquifer and the Dammam Formation aquifer, and the other figure is the groundwater flow direction, which is northeast. So the results of chemical analysis of the samples indicated that most of the groundwaters was chemically sodium, calcium, chloride and sulfate type, and chloride-bromide ratio indicated that majority of Kuwait Group and Dammam Formation aquifers showed influence of evaporate dissolution. The sulfate concentration was higher in Kuwait Group of aquifer when compared to Dammam aquifer. So here I just want to show the sulfate concentrations in two aquifers. Here the average in Kuwait Group aquifer is around 2,400, whereas in Dammam aquifer it is 1,400. So it is in the Dammam aquifer the sulfate concentration is less when compared to the Kuwait Group aquifer. So partial pressure of oxygen and sulfate concentration. The partial pressure of oxygen and carbon dioxide indicated that oxidation of hydrogen sulfide coupled with dissolution of calcite and dolomite. The relationship of partial pressure of oxygen to the saturation states of these sulfate minerals indicate that there is an inverse relationship in both the aquifers. Decrease in the PO2 increases the concentration of sulfate. The saturation index, there is a decrease in saturation of sulfate minerals with increase of PO2 values. In the graph it is shown the variation of sulfate saturation index with respect to PO2. This is the saturation index of sulfate minerals. Here variation of sulfate concentration with respect to partial pressure of oxygen in Dammam Formation aquifer. The statistical correlation of hydrochemical ionic species of the groundwater of Kuwait Group aquifer show good correlation between different ions. Chloride showed good correlation with calcium, and magnesium indicates leaching of secondary salts or dolomite solutions. Nitrate is not showing any correlation with other ions except good correlation with sulfate, which indicates the influence of oil field gas or that of similar sources. Whereas correlation matrix of Dammam aquifer in general, most of the ions are positively correlated with chloride, especially sodium, magnesium, potassium and nitrate showed strong correlation along with the negative representation of pH and calcium. The factor analysis with the eigen values larger than 1 were selected and rotated iteratively by Varimex method. The purpose of factor analysis is to interpret the structure within the covariance matrix of multivariate data collection. Kuwait Group aquifer factor analysis rendered 3 significant factors explaining 92.31% of total variance of the data set. The association of ion factor 1 representing electrical conductivity, chloride, bromide, sodium, potassium, calcium, and magnesium indicates seawater intrusion into the systems, whereas factor 2 indicates the enrichments of nitrate and sulfate, which is due to the influence of oil field. The spatial distribution of nitrate and sulfate in groundwater shows that they fall above the regions represented by oil fields. Under more strongly oxidizing condition or in the presence of certain bacteria, the sulfur becomes thiosulfate, sulfite, and finally sulfate. It may be noted that the oxidation of hydrogen sulfide to sulfur or sulfate results in the evolution of much heat. And if the earth temperature in oil regions are higher than elsewhere, some of the excess heat may be contributed by this reaction. The Dammam Formation aquifer is consisting of limestone and anhydrites of Rus formation may also inferred to undergo weathering. Hence, this factor could be mainly due to the weathering process or dissolution processes. Finally, the conclusion. The study on the groundwater of the region with reference to the higher sulfate in groundwater indicates that there are greater association of sulfate in the Kuwait aquifer than in Dammam aquifer. This fact is reflected from the correlation analysis, which is also supported by the higher concentration of sulfate around the oil fields. Thus, it is inferred that the hydrogen sulfide evolved from the reservoirs is oxidized in the Kuwaiti group aquifer, as the log PO2 values in the Dammam Formation aquifer are higher, the sulfate concentration and the saturation states of sulfate minerals are higher in the Kuwait aquifer. Further, the oxidation of this sulfide takes place, resulting in the increase of higher sulfate concentration. Also, the contour shows that it is higher near the oil fields and shows correlation with the sulfate in Kuwait aquifer. Hence, from the study, the sulfate in groundwater is mainly due to the oxidation of sulfide from the oil field and certain extent by the dissolution weathering of calcium sulfate minerals present in the aquifer matrix. It's also evident from the PCA analysis that apart from these processes, there are other geochemical processes responsible for the groundwater chemistry of the region, like seawater intrusion and rock-water interaction in Dammam aquifer, along with the ion exchange processes. So this is a conceptual diagram we have prepared from the outcome of this study. The hydrogen sulfide evolving from the oil reservoirs due to the high PO2 and high saturation index. Hydrogen sulfide is becoming sulfate in the upper aquifer more than in the lower Dammam aquifer. So more sulfate concentration in the Kuwaiti aquifer and less sulfate concentration in the Dammam aquifer. Thank you very much.